trying to figure out where we're gonna wind up before spring break. I'm starting to get a little leery on where what we have time for. So, excuse me. When you have cosine, what this says is what angle has a cosine of 1/2. So in your mind, you know that you're dealing with a positive value. Cosine goes somewhere between 0 and pi. For the cosine value to become positive, it has to be in this first quadrant. So you have to start thinking which triangle has a theta value that has an adjacent of 1 and a hypotenuse of 2. That means this is a 1, that's a 2, which means its opposite would be a 3. What angle is that? 60. That's a 60-degree angle because the only triangles that any of these values are going to wind up generating, 30/60s or the 45s. It's the only way you can do this stuff. Okay? So that tells me that this answer has to be 60 degrees or pi over 3. Okay? Yes, ma'am. Remember, when you're dealing with these, you're looking at placing your theta so that this is your adjacent, your hypotenuse, because this stands for what angle has the cosine value is 1/2. So you sit there and you have to think between the two triangles that you have. You've got your 30, 60, 90. So it's 1, 3, and 2. Then you have your 45, 45, 90, which is 1, 1, 2. So you have to remember you're placing it into one of those triangles, and then you're just going to rotate it with the reference angle. Okay. What angle has a tangent of 1? Well, good. What happens for this, in order to get a tangent value that's equal to 1, that means your opposite and your adjacent both have to be the same value. The only triangle that allows you to do that has the same value in 2 spots, is your 45. And I drew that up to the first quadrant because it said what angle has a tangent value that's equal to positive 1. Okay. 1. If it was tangent was negative 1, then I would have drawn it to that fourth quadrant. So this has to be a 45-degree angle or pi over 4. Okay. Just do the next 3. What's that? I'm getting there. What was that? 10. I don't have to worry about that, do I? I don't. The idea that you don't have to unrationalize it, because if you look at it, it's not the same value. The other one's root 3 over 3, or if we had root 2 over 2, since this is root 3 over 2, you don't have to worry about that. So you have to think in your head again, all right, cosine negative, which means I went to the second quadrant. Cosine's adjacent over hypotenuse, so that's perfect, because my adjacent then is the negative root 3. Oops. My hypotenuse is 2. So what angle has an adjacent of root 3? Which means my opposite would have been 1. It's 30 degrees. But remember, when you are in the second quadrant for cosine, that's an obtuse angle. Okay? Because cosine is found between 0 and 180. So that means the angle here is 150. Or if you remember, you went up 30 degrees for your reference angle. You went up a sixth. Those are your values. Cosine. The 30 degrees, you guys, 30 degrees is the reference angle. Reference angles are always bounced off the x-axis. Bless you. When we did sine and tangent, it was either up to 180 or up to 90 or down to negative 90. So it didn't worry so much because those were never going to be obtuse angles. Cosine's the weird one. Cosine allows you to go from 0 to 90 to 180. So your negative values of cosine are always obtuse angles. So that's why when we're here, you're 30 degrees off of this, and that's how we were able to place the right triangle and rotate into here. So when you rotate over, you're changing your x value to become negative because you go to second quadrant. This is the terminal side of the angle that goes to obtuse. There's a lot of vocab, but
so what is like that?
When,
The answer is going to be the answer of the angle of the triangle.
Correct. Yeah, because these are always the for cosines. When you go second quadrant, you're looking at the reference angle. Okay. Okay. Close-ish. You're about halfway there.
That's like I for that joke.
Come on, that was good. Okay, so that's how you get over that one. So it's 150, 5 over 6. It wasn't that great. I get points for trying.
Yeah. You get
Brownie.
I'll bring in brownies on the last day.
Oh, that's funny. All right. Yeah, let's take some time and we'll put these up and we'll check them and. So let's do this. I've got, what, 7 of them are what angle has. And then the eighth one is, what angle has of, what is the tangent of what angle has? Huh? Now remember, that last one, it just says, what is the tangent of what angle has? So you would see the inverse of that. Okay, because then if you do a double inverse, then you wind up being out of boundary and you can't make a lot of this work. Okay. No, I got some other stuff planned out for us. I just want to give this a shot, see how we do. Give you guys a minute or two to try these out. Okay. Negative 45, negative 4, 5, negative pi over 4. You okay with that one? All right. Cosine, what angle has a cosine of 0? 90 or pi over 2. Very good. Sine, negative 1/2. Negative 30, negative pi over 6. Cosine, negative root 2 over 2. Because it drops over to the second quadrant, you've got your 45-degree angle in the over there, reference angle, and you get 135, or would you say 3 pi over 4? Yeah. Root 3 over 3, 30 degrees, very good. Wait, no, it's not root 3. That's no, it's 60. Sorry. Tangent, this one. So root 3 over 3 means it's been rationalized, so it should be 1 over root 3. So yeah, it should be 30. Did you say 30? I'm sorry. Did you? I brain farted. I'm sorry. I'm sorry. Sine of 1/2. What angle has a sine of 1/2? Yeah, 30. Yeah. So I was taking some coffee and didn't answer right away. Forgive me. Can't they be thirsty?
No.
You're terrible.
At least not between 7:45 and 8:30.
Those are gross.
Your
Tangent. What angle has a tangent of root 3? Because then you have your opposite over adjacent. So your opposite is the root 3. Your adjacent is that. So your opposite is a 60. So you're 60 degrees or pi over 3. Now the fun one. I'm not doing it yet. I'm just going to move it. It usually only takes a day or two, and everything starts clicking, everything starts going. So, are you good? Ready to start this one now? Okay. When you're utilizing these style problems, think of order of operations. When you have multiple parentheses, you start at your innermost and work your way out. Okay with that? So, first thing I have to do is figure out what angle has a sine value of root 3 over 2. So that's got to be a 60 degree or pi over 3. So that means that's tangent of 60. Well, root 3, 2, 1. So what's the tangent of 60? We can make it more difficult. Yes, that's all you have to do for that. It looks awful because you all freak out. And not so many words. Well, you might have been. It's close because the initial shock and awe of that is like, then it's like, man. One of the things I wanted to remind you of when you're looking at these. Shush. So just squint and it looks good. Anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No, they're yours. There's 3. Yeah. Oh, yeah. Anyway, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Were students mean to your other math teacher? No? See, yeah. Huh. Not have the unit circle. Anyway, so when you go back through all of this, let's see, that was in. It'd be easier to show you on the actual picture. Where's the? Every time whenever I dock, all my things move everywhere around. And, did you say excuses? Oh, remember the.
Oh, yeah.
So so you don't have to yell at my drawing. When you go through this, these are all of the angles that there are, aren't there? These are all we have. You agree on that? For each of these angles, there are 3 trig functions. Now, if I double count 360 and 2 pi, is that okay? When you get into this, when you start going through it, you have 1, 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 times 3. There's only 51 questions. Really? There's a limited number of how many of these things there are. There's the pyramid scheme. Anyway, when you start getting into this, there's only so many questions that you can ask, and there are only so many answers that there are, especially working backwards. Working forwards, like what is the sine of pi over 2, things like that, you can do multiple questions of that because you can spin around multiple revolutions. Whereas when you're solving, if you really break it down even further, we're never solving for any of these. So you can back out 12. Brings you to 39 of them. You get in there even further, you're not really worrying about these 2 at all because it's just crossed out at 0. Found about 36 of them. Okay. As you really get into it, there aren't that many that you have. Okay, there really aren't. The unit circle is, it's kind of finite when it gets to when you're trying to go through these things. There's not so much. There isn't really an infinite amount of problems you can do unless I start doing like that last one I did, where what is the tangent of the sine of the angle that has root 2 or whatever it was. Okay. That's really all you can start doing with these things. So don't get overwhelmed when you see this stuff. I have some problems that we'll do similar to what we just did on the board for tonight. It's part of the giant review packet that I wasn't sure when I was going to need to use it. I don't think we don't have to worry about all of those problems. We're just going to do some of the other ones. Tomorrow what we'll do is we're going to open this up a little bit. We're opening this up to not just solving within those specific little areas. We're going to start talking about what angles have certain sine values within one full revolution tomorrow. So it's not just going to be within the boundary. We're going to look at the entire circle. So you could get what angle has a sine of 1/2. Well, sine of 1/2 is at 30, and it's also at 150 because they're both positive. Okay, that's the kind of stuff we'll start building into tomorrow. Not terrible.
Next thing you're going to tell me was the time. It was not a nine. It was the first.
What I'm looking at here really. What I'm looking at here, the last 3 pages of this are all kind of the same problems. The last 2 pages of it are all kind of the same problems. So let's do this. Let's do the left-hand column on the last 3 pages. Does that sound decent? The last 3 pages, the left-hand column, the last 3 pages. Okay. So we'll start with where it says 27, what angle has a sine of 1? Do that column. The next page says, what is the cosine of 225? And then the back page where you have secant 495. So the left-hand column of the last 3 pages. The last left-hand column, that would be the right-hand column of the left-hand column of the last 3 pages. Yeah. Yep, that's the whole point. None of the things that we're doing right now require a calculator whatsoever. Okay? None of them require a calculator at all. If you do want to go through any of the other ones, if you still have problems with positive, negative coterminals, or you need help with exact values of string functions, more of those in here as well. By all means, if you have questions, just ask. But we'll just do the last 3 pages of the left-hand column. All right? Louis, yes, sir. Yeah. I don't remember. That one might have been negative. That might be why you haven't that one might have not seen that. Yeah, that's why. It was negative, so that means it would have been in that second quadrant. So you would use the 45-degree angle as your reference, so you'd have to come up over to it, so you got 135. Does that make sense? That's why. You just didn't have the negative symbol there. Shoo-be-doo-be-doo-be-doo-be-doo.